Hey guys, I'm going to work through these kind of quick, but I just want you to be able to see them. I know they're tough problems. The first one is a pentagon. Every regular polygon, we're going to start with this right triangle. That right triangle comes from this section of the polygon. Because there are 10 of these little triangles, we're going to do 360 divided by 10. We know this angle is going to be 36 degrees, and they tell us that the radius of the polygon is 6. So I told you guys there's a secret that the adjacent side will always be the radius times the cosine of the angle, and the opposite side will always be the radius times the sine of the angle. If you want to do the trig and figure that out, you can, but r cosine theta and r sine theta are always going to be those two sides if you know the radius. But we need the perimeter. Because there would be 10 of those, the perimeter would be 60 times the sine of 36. Right, there'd be 10 of those halves if you went all the way around the pentagon here. So the area is going to be 1/2 times the base, times the apothem, which is 6 cosine 36 times the perimeter, which is 60 sine 36. I really want you practicing simplifying. Half of 6 would be 3. 3 times 60 would be 180 cosine 36 times the sine of 36. Then because they want us to round to the nearest thousandths, we type that in, be 180 times cosine 36 times sine 36. And I get 85.595. Next question. Drawing the best radius, the most helpful radius, is a big deal. If I were to draw this radius, really helpful. If I were to draw this radius, not so helpful. They're the same length, but one of them goes to the corner of the triangle. So if the radius is 5 for the circle, well, let's get the area of the circle real quick. The area of the circle is pi r squared. So the area is going to be pi times 25. So the area is going to be 25 pi. So that's the circle. The triangle, what are we going to do? I'm going to actually treat it like a regular polygon. That would be the easiest, I believe, to solve this. 360 divided by 6 would be a 60-degree angle, which means this is a 30, which means it's a 30, 60, 90. This is going to be 5 halves, and this is going to be 5 halves root 3. So the perimeter is going to be 6 times 5 halves root 3, which is going to be 15 root 3. 6 times 5 halves. 6 divided by 2 is 3. 3 times 5 is 15. So the triangle, if we use the area of a polygon formula, is 1/2 times the apothem, which is 5 halves, times the perimeter, which is 15 root 3. Multiply across the top, we get 1 times 5 times 15. Well, that's 50 plus 25. That's 75. Don't forget your root 3. And on bottom, we have 2 times 2, or 4. And it says, what percent of the circle does the triangle take up? So it's the part we care about. So to get the percent, it's the part we care about, which is the triangle. They said, how much does the triangle take up? Divided by the whole thing, which is the circle, times 100. We don't have to clean this up, but if we type that in, I get 75, I'm going to type it real quick, 75 root 3 over 4, all over 25 pi. Type in pi, do not type in 3.14, times 100. And I get 41, it actually rounds to 41.350. But this is what I typed in, this is what it would round to. This one's kind of tricky. It's not exactly like the one we did in class. This is an isosceles trapezoid, so there's some more things going on. That means when we cut off the wings, we know that the wings are the same length. They tell us that the middle section's 22, so that means on bottom, the middle section's 22, and the entire bottom is 42. So 42 minus 22 leaves us with 20. And because there's 2 wings that have to be equal, they're going to be 10 each. Now, just like the one in class, this is a 30, 60, 90 triangle over here. So we do have a 30, 60, 90 triangle. The side across from 30 is 10. That means the hypotenuse is 20, and the height is 10 root 3. So we're trying to find the area of the shaded region. Let's come up with a plan. Look at the whole thing. The whole thing is a trapezoid. So we know we're going to divide by the whole thing, which is the trapezoid. To get just the shaded part, though, we would have to take the area of the trapezoid and subtract the area of that sector. It's the whole thing minus the white would equal the shaded. And don't forget to multiply by 100. So that's the plan. So let's execute the plan. Let's find the area of the trapezoid. We can do that right now. Remember that the area of a trapezoid is the average of the bases. How do you get the average of the bases? You add and divide by 2 times the height of the trapezoid. So the average of the bases would be 22 plus 42 divided by 2, and the height is 10 root 3. So there's a few ways we could do this, but this is going to become 32, right? 22 plus 42 divided by 2, that's 32. And then 32 times 10, the trapezoid is 320 root 3. Don't have a lot of room over here. I'm going to do the circle down here. The circle, if we look careful, or the sector, I guess, the radius is 20. How many degrees do we have? We have 60 degrees. So for the circle or the sector, remember it's the angle you have divided by 360. It's how many degrees you have out of the whole thing times the whole circle, which is pi r squared. So how many degrees do we have? We have 60 out of 360 degrees times pi, and then the radius we said is 20. Clean this up. Well, that's 6 divided by 36. That's going to be 1/6 times 400 pi. That's 200 over 3. So that would reduce to 200 over 3 pi. So the circle, or the sector, is 200 over 3 pi. So let's execute our plan. Trapezoid minus sector. So trapezoid minus sector divided by the whole thing, which is the trapezoid, times 100. We don't have to clean that up, but we would have to type that in. So 320 root 3 minus 200 over 3 pi all over 320 root 3. Oh, hit the wrong button. And then multiply that times 100. And I get 62.213. Nice. All right, here, several ways you could attack this. I mean, a lot of you might do this and do 1, 2, 3 rectangles. And that would get you, that'd be fine. But I would actually close the top. And I would do the whole thing, which is 15 times 30, minus this piece that is gone. That looks easier to me, which is 8 times 10, or 80. So 15 times 3 is 45 out of 0, minus 80. 450 minus 80, and there's our 370. There's a few ways to get there, but boom. Decagon, apothem, I know what I'm doing. Drawing my right triangle. How many of these right triangles? If n equals 10, because it's a decagon, then 2n would be 20. It means there's 20 of these. 360 divided by 20 is 18 degrees. That's the first thing we do every time. Apothem is 9. I need this side. I'm going to call it x. So that is the tangent of 18 equals x over 9. Multiply the 9 over. If x is up high, all you got to do is multiply. So there's my apothem. Nope. This is my apothem. This is my x there. So I need to know the perimeter. Well, there would be 20 of those. 20 times 9 is 180, and then it's tan 18. So the area will be 1/2 times the apothem times the perimeter. Boom. Half of 180 would be 90. 90 times 9. How do we do 90 times 9? It'd be 90. That'd be 810. So we're talking about 810 tan 18. And I get 263.185. Please practice simplifying it, though. 810 tan 18. The area of a rhombus is 80 units. If one diagonal is 5 times the other. Okay, so diagonal 1, I'm going to call it x. Diagonal 2 is 5 times that size, 5x. Find the perimeter of the rhombus. So we know the area of a rhombus is d1 times d2 divided by 2. Plug in what we know. We know the area is 80. We know that x is d1. We know that 5x is d2 divided by 2. Multiply the 2 over, I get 160. 5x times x would be 5x squared. Divide by 5, and you would get x squared, and that would be 20, 12, 32. Take the square root, and you would have 4 root 2. It would be plus or minus 4 root 2, but you can't have negative 4 root 2. So I know that one diagonal is 4 root 2, which means the other diagonal is 5 times that size at 20 root 2. Draw my rhombus out, and I know that I have one diagonal. The entire diagonal is 4 root 2. So half of it would be 2 root 2. The other one is 20 root 2, so half of it would be 10 root 2. And to get the answer, which is the perimeter, I'm going to need this side. I'm going to call it x. Well, on a rhombus, that's going to be Pythagorean theorem. That is going to be the square root of 10 root 2 parentheses squared. If you don't use the parentheses, you're going to get it wrong if you're using a calculator. 2 root 2 squared. That's 100 times 2. That's 200. That's 4 times 2. That's 8. That's the square root of 208. That's 4 root 13. So one side is 4 root 13. So the perimeter is 4 times 4 root 13, which is 16 root 13. 16 root 13 is the final answer. Perfect. Find the area of the polygon, parallelogram. So opposite angles are equal, I know that, which means that the other corners have to add up to 180. It's a parallelogram, so opposite angles are equal, consecutive angles are supplementary. Opposite sides are equal, so there's the stuff I know from the picture, and I want the area. Remember, there's two choices. We could drop a height this way, or we could drop a height this way. We've talked about that several times. Heights have to be perpendicular. It doesn't matter which one you do. Doesn't matter. I'm going to do the vertical one here. If I do that, I have a right triangle here with a 60 and a 6. This would be 30, so this would be 3, and this would be 3 root 3. So the height would be 3 root 3. So area of a parallelogram is base times height. On this one, the base would be 14, and the height would be 3 root 3. Multiply that out, 42 root 3. You get the exact same answer if you drop the height the other way. Promise. The figure is a triangle on top of a rectangle. So triangle and rectangle. The area of the rectangle is 250. The length, the long side of the rectangle is 2.5 the width. So I'm going to call this x. I'm going to call this 5 halves x. That's 2.5. I like fractions. They're easier to use. If the area of the triangle is that, what is the height of the figure? All right, so we know that the length of the rectangle is 2.5 the width, and we know the area of the rectangle. So if I work on the rectangle, area equals base times height. We know that 250, right? They tell us the area is 250 equals the base 5 halves x times the height x. That would be 250 equals 5 halves x squared. How do you undo 5 halves? You do times 2 divided by 5. So it'd be 500 divided by 5 would be 100. So x equals plus or minus 10, but it can't be negative 10 on this one, so it's just 10. So that's 10. And then 10 times 5 divided by 2 would be 50, would be 25. So this is 25. Let's switch over to triangle. We know the base of the triangle is 25, and we know the area of the triangle is 175. A triangle, so if I'm working on the triangle, is 1/2 base times height, and we know the area is 175. Equals 1/2, the base is 25, and we can solve for the height in that case. How do we undo this mess? Well, we could, how do we undo times 25? We divide by 25. That would be 7. And then how do we undo 1/2? That'd be times 2. So this would be 14 equals h. So this height is 14, and this height is 10, so the combined height has to be 24. I like it. Next questions. The diagonal of a square is 8 units long. What is its area? You could do this 2 ways. Remember, a square is a type of kite. So you could do 8 times 8 divided by 2, right? Area would be 1/2 d1 d2. Or could you divide by root 2 and know this is 4 root 2 and 4 root 2? So could you do area equals 4 root 2 squared? Either one. Same answer. You're going to get 32. The apothem of an equilateral triangle is 3. So if I know the apothem of an equilateral triangle, I'm going to treat it like a regular polygon. So I need to draw this triangle. Angle at the top would be 60, right? 360 divided by 6 would be 60. And I know the apothem is 3. So that means that this would be 3 root 3. The perimeter would be 6 of those, right? There'd be 6 of these on a triangle, right? 6 of those. So 6 times 3 root 3 would be 18 root 3. So this area would be 1/2 times the apothem times the perimeter. That's going to be 9 times 3. That's going to be 27 root 3. And then the apothem of a square, I didn't do any of that in class, but you can figure this one out. But at the apothem of a square, what do you think happens on the apothem of a square? If you said it's half the side, you are correct. So the apothem of the square is 3. Well, that could go both directions, making the entire height of the square 6. So the area of a squared is side squared, so that would be 6 squared, 36. Good questions. I like them. Find the area of the shaded region, hint EI. So they tell you how long EI is. That's this one. So EI is that number, round to the nearest thousandths. Well, the name is Kite. Here's the thing. If I draw EI here, so something I'm seeing is I know that that's 4. I know this is 4 because those are both a radius. We have a right angle. And they both use the exact same hypotenuse. So I know it is a kite because I know these two right triangles are the same right triangle. So I know it's a kite. So this angle would be 50. This angle would be 50. If this is 90 and 90 and 100, 90 plus 90 plus 100 is 280. So 360 minus 280 would leave you with 80 degrees. That means this is going to be 40 and 40, or I'm a bozo, 90, 50, and 40, right? Could use just the triangle. Okay, so now I have that right triangle information. So there's a few ways I could approach this. We could do like area of a kite work. I could drop this. They already told us how long EI is, right? They told us how long EI is. Could I get the length of KT and do 1/2 D1, D2? I sure could. Could I get the length of KI and do 1/2 base times height? And then that'd be one triangle and then double it because there's 2 of those. I sure could. It doesn't really matter. There might even be more ways to do it, but I'm going to do it this way. So I'm going to get this number. So I'm going to work on this small triangle. So I have a right triangle here with a 4 and a 50. So I have a 4 and a 50. I need this side. I'm going to call it x. That's going to be the sine of 50 equals x over 4. So x equals 4 sine 50. 4 sine 50. Now that's half the diagonal. So on this problem, D1 equals 4 divided by cosine 50. They told us that. D2 would be 2 of those, coming in at 8 sine 50. So our final result, the area is 1/2 times D1, which is 4 divided by cosine 50, times D2, which is 8 times the sine of 50. Half of 4 is 2. 2 times 8 is 16. I have a sine 50 on top, and I have a cosine 50 on bottom. And let's hope that that's the answer. 16 sine 50 divided by the cosine of 50. Oh my. I messed up somewhere. This is the last question. So let me take a look again. It's possible I didn't make a good question, and maybe I solved it a way that doesn't work. EI is that entire diagonal, 4 divided by cosine 50. And that makes sense. Okay, I agree with that. Focusing on that little red right triangle, we have a 50. Sine of 50 would be equal x over 4. Oh. I did the thing I always complained to you guys. It's find the area of the shaded region. I found the area of the kite. Okay, I was getting really worried. There's the area of the kite. I need the area of this sector now. Ah! Okay, I was like, what in the world? I didn't read the question. Remember I said read the question? I always say read the question. This sector needs to be removed. That's a 100-degree sector with a radius of 4. So all this work is the kite. Let's do the sector. So the sector, remember, is the angle you have out of 360. That's the percentage of the circle that you're working with, times the area of the whole circle. So on ours, we have 100 degrees of our circle out of 360. And that would be pi, and our radius would be 4. So 4 squared would be 16. 100 over 360 reduces, that'd be 10 over 36. 10 over 36 would be 5 over 18. And make this 16. 16 over 18 would be 2 times 8 and 2 times 9. So 8 times 5 is 49 over pi. So it's going to be, the answer is going to be 16. It's going to be 16 times the sine of 50 divided by the cosine of 50. That's the kite, minus 40 over 9 pi. That's the white space. That's the sector that's gone. So minus 40. Let me type this in. Now I got it. And that does, in fact, give us our 5.105 answer. All right, guys. Hopefully that was helpful. I like these questions a lot. They're a lot of fun.